Good morning, everyone. My name is Tina Abbey, and I'm the Associate Director of Alumni and Constituent Engagement. Welcome to the St. John Fisher College's 6th First Friday lecture of the 20 and 21 season. The First Friday lecture series is designed for alumni and friends of the college who are interested in hearing learned perspectives on a variety of topics from members of the St. John Fisher College and Greater Rochester community. This lecture season is virtual as we cannot be on campus together. As a reminder, the chat feature is available for questions during the lecture. You can find that at the bottom of your screen with the text bubble icon. If you click the icon, a text box will appear and you can write your questions in the box. We will address all questions in the chat at the end of the lecture. I am honored today to introduce you to Dr. Kristin Picardo, Professor of Biology and Director for Student Research and Creative Work, and Dr. Sarah Goodman, Assistant Professor of Psychology, as well as two of our senior students, Molly Taylor and Andrew Clark, both of the class of 2021. They will give us a sneak peek at our Student Research and Creative Work Symposium today. Molly is a psychology and Spanish double major, an exemplary student, as well as outstanding member of our campus community. After graduating in May, she will pursue a PhD in education with a focus in educational psychology at Virginia Commonwealth University, where she'll study motivational processes related to student and teacher success in education. Andrew is a senior biology major with a chemistry minor, as well as a science scholar. He has been doing research for 3.5 years at Fisher. Andrew played football for his first 2 years on campus and is currently in the process of formulating a mentor program with the natural science at Fisher. After graduation, he plans on taking a gap year and working for a pharmaceutical company in Boston or participating in a post-baccalaureate research fellowship at the National Institute of Health. Upon completion of his work, he hopes to get accepted to a medical school and pursue his passion for helping others. During our lecture today, Dr. Picardo will share the different aspects of the important work of the center and give examples of student research at Fisher. Dr. Goodman will share what it means to be a research mentor and how this impacts a faculty member's professional experience. Please join me this morning in welcoming Dr. Picardo, Dr. Goodman, Molly, and Andrew.
Good morning, everyone. Thank you, Tina and Matt, for inviting me and my fabulous co-presenters. And thank you to everyone who is here with us on the webinar for sharing your morning with us. So let's see, I'm going to try to make this full screen. Matt, can you give me a thumbs up if this looks okay? Thank you. Okay, great. So I have the pleasure of talking with everyone today about our Center for Student Research and Creative Work here at Fisher. So shown on this image is one of my most favorite pictures of the Fisher campus. It is in the fall, the gorgeous colors. It always brings a smile to my face. But at the bottom are really the stars of the show. So our student researchers come from any discipline at the college. These are all undergraduates that are depicted here. With the exception, I think, of the far right photo does have some pharmacy students pictured and faculty. And so you can see these are just some snapshots, and I'll show lots of pictures this morning. Snapshots of what do these activities look like. So on the bottom left, this is a student who is presenting her research poster on the Fisher campus. The next picture over to the right, this was my student Elijah, and he was working with me last summer. Summer of 2020 was all remote. And so I said, send me pictures of your research environment from home. And this was Elijah, hard at work, lots of computer time, but research didn't stop. So we found a way. The photo in the center on the bottom, these are 3 students who attended an honors conference, and they are pretty proud, showing us their presenter badges. One photo over further, this is a student in the biochemistry research lab, and you can see he's in his lab coat and he's hard at work. The last picture on the right was, I believe, taken at our very first symposium, and we will finish my section today talking about the symposium. Okay. So we do have a vision and mission here for the center. It guides our work. The Center began in 2016 under a strategic initiative at the college. So really had to put some ideas together, start to get organized and convince everyone that this is something that was right for Fisher. Turns out that the center was operationalized in 2018, and it's something I'm very, very proud of. And the successes that I share with you this morning are truly a testament to the work of our very committed faculty and staff that serve as mentors, and our amazing students that really are hungry to dive into projects. We know that undergraduate students can go deep into a discipline or a topic, and they engage in this practice through undergraduate research. They have faculty mentors primarily, though some staff have participated more recently as mentors with their expertise. The students gain workforce readiness skills, for example, communication, critical thinking, and teamwork especially. Students participate in a research project, and this can set them apart from other candidates as they move forward to their next steps, graduate school, job applications, whatever it might be. So a photo shown here is actually of the last group of summer science fellows. And this is to just bring us back a little bit further in the history of student research at Fisher. In 2011, the summer research program itself began. So not the center, but the summer research program. And it was heavily focused on the sciences. And since that time, we're really excited because with the center coming online, we've expanded these opportunities for students of any major. We now have incredible representation, a broad array of different majors and students engaging in research in the summer program. So what was the Summer Science Fellows program is now Summer Fellows, to be more inclusive. Students need to have good academic standing, so GPA of at least 2.0. We don't ask for a very high GPA because we know that this experience can be transformative. And so we want that experience open to as many students as possible. Over the past few years, the students that participate in this 10-week Summer Fellows program, we have around 30 to 32 students and around 18 to 20 mentors. So that makes sense since some mentors do take more than one student in a particular summer. How do we fund this really exciting work? Well, first of all, students can make a choice. Do they want to earn course credit and therefore their award for the summer program is a tuition waiver? Or is this 10-week program actually taking the place of what would be their summer job? So they have the opportunity to be paid a stipend and can work up to 35 hours a week. That can be tailored down because we know our students have other commitments and responsibilities. So how do we fund that? The college supports the majority of this, but we have been very successful in summer 2020. I'm very proud. We had a milestone achievement. 18% of our summer budget was covered through external funds. Some of this comes from grants that faculty have been more and more successful at Fisher in securing. And I'm very excited because they include funding to support undergraduate research. This has been a major shift in how we operate here at Fisher, something I'm excited about, and I know will continue to grow. And also gifts from donors and alumni and friends of the college support these students. It's wonderful. The students then work through that 10-week program, and in August, President and Mrs. Rooney have been so gracious to host the President's research reception, and we have a gathering, we celebrate. It was a busy summer, and we're ups and downs, and it's a wonderful culmination. We get together and share experiences and celebrate, and then we are all energized for the next semester to begin just a few short weeks after. The students that participate in Summer Fellows are all required to then present their work at the following April Symposium. So because the students and the mentors are the stars of the show, yes, we have Andrew and Molly here today, and you'll hear from them live for a sneak peek, but I do want to share more students' experiences with you. So pictured here at the top is Jacob Vinch. He will graduate also this year, this May. He's an economics major, and that's a picture of Jake, summer 2020, working at home on his research project. He actually went on to present this work at the New York State Economics Association conference, which was a wonderful opportunity for him to engage and disseminate his findings in a professional setting. Pictured on the right, this is Trevor Smith with his mentor, Dr. Kamaru, in chemistry. And they were doing bench science research on the Ghanaian tiger nut and thinking about the chemical properties in the body of research around the nut. Pictured on the bottom left, this is Jeff Lenish. He graduated a year prior. He was a computer science major. And so you can see there's a broad breadth here of disciplines. We're really excited because we have started to grow our research opportunities with our external community, as well as engaging students with faculty and staff on the work that Fisher does. And so we think of this as our external community and our internal Fisher community. And President Rooney, over the past handful of years, has supported an additional summer fellows program called the Presidential Research Fellows. And this is heavily focused on community. So 2 examples are shown here. On the top, this was actually a snapshot of a poster that Abigail Darren Finko produced for the symposium last year. She is a nursing major, and their team project focused on the Rochester Monroe Anti-Poverty Initiative. She worked with a team of other students and multiple mentors, and this was something that was pretty exciting to see the group and the teamwork that they built over the course of the summer. The bottom photo is the 5 students that worked with Dr. Carolyn Baca, our professor and chair of history. This was the summer of 2019, and that they tackled a project called No Better Soil, the Neighborhoods of Frederick Douglass. These students went on to present at the 2019 National Association of African American Studies and Affiliates Conference that was co-hosted here in Rochester by both Fisher and Nazareth College. Research happens off campus too. This is one of my most favorite pictures because not all of us get to be in Costa Rica, like Jenna is shown here in the large picture on the left with her amazing starfish. She was mentored by Greg Cunningham, a professor of biology, and her majors were biology and sustainability. So yes, research happens off campus. I showed you the at-home photos, pandemic related, but there's opportunities for students when they study abroad, either formally or through alternative spring break experiences, or perhaps mentors have research affiliations somewhere else outside of Rochester. Students can work with the mentors and conduct their research. The top right picture, this is Andrew Apiaget, and he graduates this year as well. I'm getting a little sentimental this morning, all these seniors graduating, guys. Try and hold it together. So Andrew is an international student, and he's from Ghana in West Africa. And he went home, I believe it was the summer of his right after his junior year, and he worked at the Institute for Medical Research there. And here's a photo of him at the microscope. And he had, the equivalent experience of entering your first year of a PhD program. We spent lots of time on the phone, international phone calls, with all of the ups and downs that brought and all of the growth that he experienced. It was a phenomenal experience for him. Pictured in the bottom right, this is Maria Robinson. So the summer after her first year at Fisher, she engaged in a research project. So to share with you that students from first year through seniors, and if we're talking about undergrads, are actively involved in research. There's a place for all students. Okay, our students win awards. They're scholars. They are recognized on a national level. And here are 3 examples. So Alex Friedenberg is in a picture on the left. He graduated in 2019. Alex is who has his sights set for anesthesiology. So he's a couple of years into his medical program. It's always great to get text messages on, some update or paper Alex is seeing that he wants to share back with us. Alex was one of 20 students accepted among graduate students, postdoctoral scholars, and undergraduate students out of 400 applicants nationally. And he got to go to the ASBMB, so Society of Biochemistry and Molecular Biology Hill Day, so in Capitol Hill, and he got to do some advocacy work. Pictured on the top, this is George Roba on the far left, and he is with his pals in biology, Zai and Alex. And George actually was a Farish scholar when he was here at Fisher. He won 2nd place for the award for excellence in student research at the National Tri Beta Biological Honor Society Convention. And they got to go out west. You see the Pacific Ocean in the background. So a wonderful experience for them. George actually conducted research both in psychology and biology. You see, he's a double major. And so not only are students engaged from first year through through their time as seniors, depending on when they want to get involved. But students with multiple academic interests can get involved in research in different disciplines while they're at Fisher. And finally, on this slide, pictured on the bottom right, this is Maura Connerton. Maura graduated last year. She's pictured here with her Drosophila cultures, her fruit fly cultures in the laboratory with her mentor, Dr. Ed Freeman on the right. She earned a competitive fellowship through the Endocrine Society. This provided her a full stipend for her summer research with Dr. Freeman and financial support to attend that national meeting and expo. This is a fellowship that Fisher students in the past would not have been qualified for, but because of her research experience leading up to that point, she was selected, and we're very proud of that. Some additional research accomplishments, recent accomplishments that the center is very proud of. So sort of at our stopping point of today, over the past 4 years, we've had 111 students participate in summer fellows. We've had 180 or more students that were supported for participation in conferences and events. So there's a mechanism through the center where the student can say, I want to register and attend this regional or national conference. And the center has a mechanism to help offset the costs for students to be able to do that. We've had 800 student participants in our symposium, years 1 through 4. Registrations continue to come in. They are due Monday night. So we had a couple laughs a few minutes ago. Students will be busy this weekend, and I'll be busy fielding questions as students register for our virtual conference this year. So we'll push that number up past 800. We have 3 faculty that serve as elected counselors with the Council on Undergraduate Research. So Fisher is an enhanced institutional member of CUR, Council on Undergraduate Research. They are the nationally recognized expert body on all things undergraduate research. And myself and Dr. Goodman, who you will hear from in just a minute, as well as Dr. Bruce Blaine in Math and Computer Sciences, have been elected, and we serve in this capacity externally. In addition, we have done some interesting things on a more external scale. So Fisher was chosen for participation as a pilot campus in a National Science Foundation grant that focused on developing a tool that serves as a mentoring guide, as well as collects assessment data on programming. And so Fisher got to have a voice in a national conversation on student research, mentoring, and assessment of the high impact practice of undergraduate research. And so what we're getting excited about is, of course, our symposium. This is our culminating event. It's a wonderful day of celebration normally when we are able to be together on campus. The bottom right picture is one of the first events we held. We're busy, we're getting to hear from students. They become the experts for the day, and all of the faculty and staff and guests get to be the students. It's a wonderful, wonderful juxtaposition. President Rooney has been so kind to provide some welcome video clips for our virtual events. Last year needed to be held virtually, and this year we will as well. And I would love to invite each of you to attend. So this is the first year we've been able to have a really easily accessible platform. So it will be virtual. There will be a web link that Tina can share out. The event will open on April 28th online and run through May 2nd. It'll have pages for each individual student presentation. You might see a poster, you might see an oral presentation, a video that the student created. And then there will be chat features for questions and answers, and of course, compliments. On Friday, April 30th, we will have live Zoom sessions. I have more than 20 students already signed up to give oral presentations live on Zoom, and we will provide all of that information for you to join us there as well. It's been my absolute pleasure to serve as the founding director as the Center for Student Research and Creative Work continues to grow and expand and find new ways to see our students engage and advance. Now I would like to turn things over to my colleague, Dr. Goodman.
Thank you, Dr. Picardo. I think before I get started, I really need to acknowledge Dr. Picardo's leadership through the center. The center is such a tremendous source of growth and of opportunity for our students. And without her tireless commitment to making this a wonderful place and a wonderful opportunity, it wouldn't be what it is. And so the students benefit, the faculty benefit, and she has so graciously given me a platform today to wax a little poetic about what it means to be a mentor, which is a role that I love, I think, the most in all the things that I do. So you heard a little bit about the Summer Fellows Program, a lot about the Summer Fellows Program, and how the center is instrumental in facilitating this program. And so as a mentor, what I have the opportunity to do, and so I'll speak from my experience, but I think this maps on to other folks in other departments and in other capacities. But I have the opportunity to partner with a couple of students every summer to work on some project or another. And this project could be a project that I have sort of spearheaded and developed, and I'm looking for some help on. And in some cases, like you'll hear from Molly Taylor later, an entirely student-initiated, sort of self-guided project that just needs a little bit of mentorship support. And so these projects look different depending on the need and depending on the student, but regardless of the shape that they take and the need, they are a tremendous opportunity for faculty to kind of explore a new role as a research mentor. So as a mentor, I get to work with students in this 10-week program to help them achieve some subset of goals for moving a project forward. And sometimes the real exciting part is when we're a little too excited at the end of the summer and we just can't stop, right? So we carry it over into the fall semester and in the spring. And so I've had the benefit this year of working with both of my summer fellow students into the regular academic year. And we've worked all year long on these projects, and they have become these beautiful representations of good science. And there's just been so much growth. It's been quite a bit of fun. So as a mentor, I get to guide and support students as they sort of venture into this unique academic experience of doing their own research. In the classroom, a lot of times we're in this space with students where we're helping them learn what there is to know. And when we get to see students as researchers and we get to mentor them as researchers, we start to help them generate knowledge, right? Brand new information. This is an academic frame shift, which is one of the more fun things about this job. With that, though, is kind of a big leap in terms of agency and efficacy for our students. So a lot of the work in this mentorship space for us as faculty is in the personal and professional development. A lot of that comes through exploring what it means to fail in a research capacity. And I could talk about failure all day long, and I will not. But Dr. Picardo and Molly both know how much I love to talk about failure because it's an integral part of growth. The error, the frustration, and the learning how to take and incorporate feedback are all really necessary, important aspects of the self-discovery process and the identity development that is so critical for our students as they move through their degree program at Fisher. So one of the fun things about being a mentor in this space and sort of helping students learn how to navigate the choppy research waters is about breaking down bias in perceptions of success. So I think students, come into college, and a lot of times they think, well, our faculty are here because of just unbridled, unmitigated, success nonstop from day one. And so to get to shift that narrative a little bit and start talking about, the difficult points and the sticking points, and how do you come up with strategies to navigate those critical moments, that's where the real growth comes in. And for me, that's the value of my role as a mentor, is in helping students not so much achieve a research outcome, right? A publication, a poster, those are wonderful, but helping students master the skills and strategies and abilities that research demands allows them to become these agents of academic change. And that is the rewarding part. We start to see our student collaborators ask really good questions and arrive at really sound conclusions. Some of the most fulfilling conversations, I think back to one of my first meetings with Molly this summer, and she came to me with a list of papers and she was reading them, and I had an idea that I kind of chucked at her, and I was like, I know we're going to work on this project, but I have this thought, what do you think about this? And the next week she came back with what we like to call in improv comedy, it's like yes and. She just says yes and here's a bunch of other stuff I thought. And so it developed into a secondary project. So now we're working on 2 projects instead of 1. And the creativity that we see in these research spaces is incredible. Our students are amazing, and we just get the benefit of getting to sort of facilitate them along the way. There's a point with students where we see them transition to saying, well, I don't know if I can find the answer, right? They go out into searching the literature or digging into what's known, and they're like, well, I can't find it. It must be me. And at some point in our mentorship trajectory, that pivots just a little bit, and they realize that the answer isn't out there because they have to create it. They have to find it. And that pivotal moment is, I think, the genesis of autonomy in research. And that is so fun for our students. Like Dr. Picardo said, the problem solving, the troubleshooting, the resilience and the communication skills that students develop in doing research through these programs is certainly useful in academic careers, but it's instrumental in any direction our students choose to go after Fisher. And so to see the openness of these programs and to see the opportunity for any student to come in and just pursue a little bit of research as a way of sort of sparking an interest is starts a trajectory of growth that really follows them through into professional development. So one of the other, I think, really rewarding and fun things about being a mentor is challenging our students to dismantle what feels like a power differential in research space. So oftentimes I ask my student collaborators for feedback on my work, right? I'm writing this thing, tell me what's wrong with it. And you could imagine, like, if you sort of rewind yourself back to your early years as an undergrad, how that might be a little bit uncomfortable, right? Well, how could I possibly give feedback to someone who allegedly knows so much more than me? And some of the best feedback I've gotten on my work, on the things that I'm interested in, have come from my collaborators, right? So there is this shift from student to collaborator, from teacher to student to peer to peer. And that is, I think, a testament to the transformative nature of student research. So selfishly, really selfishly, mentoring students is, I think, just as impactful for me as a faculty member and as a scholar as it is for our students. A lot of times we get stuck in these ways of thinking, these patterns of approaching problems that are really singular, and to have a fresh perspective, a student collaborator who's willing to yes and meet me where I am and just say, well, what about this, is so enlightening and is so challenging in a good way. That it leaves me excited about the work that we share and the alternative approaches to the work I currently do on my own. And I'm just so appreciative of the enormous capacity of our student researchers to approach these tough problems in these really innovative ways. They are some of the most incredible people and have some of the most incredible opportunities at St. John Fisher through this program. So without further ado, I'm going to stop talking. I love mentorship. I love doing research, but what I love more is hearing our students get to talk about their work. So I am going to reintroduce you to Molly Taylor, who was one of my 2 summer fellow students this past summer, who started her work on motivation and self-efficacy and self-regulation in college students in the summer, and that has carried through into what is now a departmental honors project, which means that she will, in a few weeks, defend her independent research study that has taken 3 semesters in front of a faculty panel, and will ultimately achieve departmental honors, which is very exciting for us. So take it away, Molly.
Thank you. So I'll just share my screen real quick. Okay, so my summer research project was essentially an extensive literature review, kind of going through the mechanisms through which students are able to self-regulate, as well as their adoption of specific goal orientations and how that interacts with their self-regulation. So my advisor was Dr. Goodman, and the title of my project was, does goal setting serve as cognitive resource management, college students' adoption of goal orientation as a self-regulatory strategy? So first, we have to kind of define what is self-regulation, because a lot of people will just assume, oh, self-regulation is self-control. It's putting down your phone while you're working. Well, it's a lot more than that, actually. And instead, it's a very cyclical process. So it constantly repeats as we begin and complete tasks. And so we first plan, and then we act, and then we reflect on those actions. It also involves a sense of personal agency, which is our ability to originate and carry out specific actions. And of course, those thoughts and actions have to be geared towards some end goal state. So essentially, self-regulation involves the whole process of pursuing goals where we have to actively think, act, and then reflect. So Barry Zimmerman, who is an esteemed researcher in the field of educational psychology, formulated this widely accepted model that outlines the 3 phases of self-regulation. So first we have the phase of forethought or planning. And that kind of begins with task analysis. So to do that, we set goals for the specific task that we're planning to achieve. And that goal setting can either be done with proximal, meaning short-term goals, or distal, meaning long-term goals. Forethought also involves strategic planning, or understanding what sort of cognitive strategies we're going to use to tackle whatever task is in front of us. So for example, we may use a strategy of rote rehearsal by learning with flashcards, or using repetition by writing down vocabulary 10 times over, just to help us kind of remember things. And using those specific strategies also helps us reflect upon our performance, because then we can say, oh, I succeeded or I failed because I used this specific strategy, and next time I'll adjust. So then we go to the volitional control phase, or the performance phase of completing a task. Here we use self-control to keep our attention focused. We observe our own actions to see if they're working in the moment. And we make use of our resources. So resource management, which is essentially understanding how we prioritize our time, our energy, and our physical materials. And we'll actually come back to the question of resource management later, because it's a really important part of the research that I am doing. So finally, we come to self-regulation, where we give ourselves feedback on how well the task or goal was completed. We also use self-judgment to attribute our outcomes to either the strategies that we used or our own abilities as a student. And then lastly, we use self-evaluation to compare our performance to other measures. So for a mastery comparison, it would be, how much did I learn? For a normative comparison, it would be, well, how did I do compared to peers? Previous performances, well, how well did I do in the past? And collaborative is, how well did I contribute to the group? So then the other part of this whole big research question is goal orientation. And when we adopt certain goals during the forethought phase, they can be classified as either performance approach, performance avoidance, or mastery. So with performance approach goals, the whole point is to demonstrate your superior ability compared to others. So this would be like, I want to earn the highest grade in the course compared to my peers. Now, performance avoidance goals is really the opposite. So avoiding the demonstration of incompetence compared to your peers. And this is associated with a lot of test anxiety, because you're really afraid of failure and the perception of failure. So it's not really great for academic achievement, because we start to set lower goals and we're just really scared about failing in our endeavors. Then we go on to a mastery orientation, which our primary goal is to improve ourselves and to deeply learn new materials and new skills. And research shows that mastery goals are often correlated with greater intrinsic interest in the task, because there's no concrete end goal that you can either fail or succeed at. It's really just aiming to improve. And they're also associated with setting more challenging goals, because it allows the individual to learn without the fear of failure or comparison against peers. Now, the question is, what strategies should I adopt? What orientation should I adopt? And a lot of previous literature places emphasis on mastery goals in education because it has shown that mastery goals lead to more intrinsic interest in learning because the subjects that you engage in are things that you enjoy and you want to devote more time to learning deeply. Also because the goal here is just to maximize your learning and your personal growth, students tend to use learning strategies that help them deeply learn information, such as teaching other students the material to help you learn it better. Another benefit is valuing the task more because you enjoy it. So you can say, this is going to be really helpful in my life. And the last major benefit is decreased test anxiety because you don't focus on performance compared to others and there's less fear around failure. So instead of seeing a test or even failing a test as a bad thing, you see it as a learning opportunity. Well, all of this sounds great. Does it really seem realistic given our academic environment? Because I don't know about you, but it's really hard for me to see failing a test in college as a learning opportunity because it directly affects how I'm graded and it affects my supposed worth as a student. So here's where the benefits of performance approach goals come in. Approach goals can still have increased intrinsic interest, especially for students that enjoy performing well in the classroom and enjoy competition. Approach goals have also been shown to be highly correlated with greater self-efficacy or our beliefs about our own abilities. And once you are successful in achieving a performance approach goal, that also increases self-efficacy. And probably the most distinguishing factor of performance goals is that they significantly predict greater academic achievement as measured by GPA or singular exam grades. So of course, when our only goal is to outperform others, we end up scoring higher on measures like GPA and test scores because we don't need to deeply encode what we learn, we just have to perform well. Not to mention the current educational system is set up in a way where students are evaluated based on GPA. So maybe performance approach goals do have an adaptive goal or adaptive role in learning. So if we could adopt mastery goals for every task, every assignment, every course, maybe that would to the greatest amount of long-term learning and personal improvement. But there's such thing as limited cognitive resources. So that might not support mastery goals at all times. And this is where the concept of ego depletion comes in. So ego depletion can be described as a state of almost like cognitive fatigue, where any act of self-control or act of choice depletes some sort of limited mental resource that we have. Mastery goals use a lot of self-regulatory and cognitive learning strategies, and that depletes those mental resources. And that obviously leads to ego depletion. So then that decreases our brain's ability to self-regulate in our thoughts and behaviors. So then we end up setting lower goals and future performance decreases. But if we were to adopt performance approach goals for appropriate future tasks, then we could manage our cognitive resources better for different tasks or subjects, and that can help us manage our overall resources and at the same time maintain that really high level of academic performance. So following the research I did for the Summer Fellows Program, I created a revised self-regulation model adapted from Zimmerman's 2002 model, in which resource management becomes a part of the planning or forethought phase. So when deciding what goals to adopt, we first have to take into account our interest in the task, our autonomy or choice in completing the task, and how much we value what we're learning and what we're doing, all of which falls under the category of our motivational beliefs. So once we understand all of those constructs, then we can manage our cognitive resources and decide what types of goals we want to adopt for the specific task to help us accomplish what we need to accomplish. So following the Summer Fellows Program, I began my research for the Psychology Department Honors Program. And for this research study, I created a questionnaire in which participants were given scales to measure their cumulative GPA as well as their major GPA related to a course that they take for their major and their GPA for a course that they take for the college course, so something that they're required to take. And basically I was trying to see if students higher in self-regulation ended up adopting different types of goals for their different types of classes because they would be better at managing those cognitive resources. So participants were also given scales to measure their goal orientation for each course, their self-efficacy overall, their self-regulatory skills, their use of learning strategies while learning, their effort in both their major related and their core-related course, as well as their mindset or their beliefs about intelligence. So I'm currently completing the data analysis stage of the research project. So I don't have any concrete results yet, but it should be hypothesized that students with greater self-regulation will adopt different goal orientations for their major related and their core-related classes because they'll be better at that cognitive resource management. That being said, it's probable that most students will adopt mastery goals for their major related courses and performance goals for their core-related courses because students are more likely to have greater intrinsic interest and task value in courses related to the major that they decided to study in. And finally, it's hypothesized that both mastery and performance approach goals will lead to greater academic achievement. Because this is in line with previous literature, both goals do end up facilitating learning. However, it's likely that performance approach goals will lead to a slightly higher GPA in their major course or their either course, because again, the goal here is solely to outperform others and to get your GPA up as high as possible. So the aim for the results basically is to show how the nature of performance approach goals can allow students to leverage goal setting, and that aids in achievement without sacrificing cognitive resources. And if you have any questions, I put my email up on the screen, or you can add them in the chat. And I'll hand it off to Andrew.
Thank you very much, Molly. I appreciate it. Congratulations on such great achievements and your continued success through your research. I appreciate it. So I'm just going to begin by sharing my slides. Give me 1 second. And if I can just get a thumbs up or somebody come on audio and tell me if you could see that. Oh, sorry. Oh, maybe not. Hold on. All righty. Slow start. Okay. All right, great. So my research endeavors. So my name is Andrew Clark. I'm a senior biology major with a chemistry minor. I've been a chemistry learning assistant for 3 years now. And I have also, in conjunction with a few professors, started to create a mentor program devoted for the first year students in the natural sciences, really focusing on career development, the essential tasks, what it's required to be successful in the college curriculum and moving forward into their career. I'm also a science scholar, like it was initially said, and I've been doing research here for about 3.5 years. I originally came in starting a project with cardiac heart regenerative medicine and therapies with Dr. Ed Freeman, who was talked about earlier. That lasted for about a semester. And then currently I've been working on the localization of PA and AIFM1 interactions with influenza virus. I also want it to be noted that I'm a co-winner of a Rochester Academy of Sciences grant, to which our project budget was fully funded. Let's see. Oops. Okay. So my current project and some of its background. So as you can see to the right, this is influenza virus. And influenza is a single-stranded RNA envelope virus that is responsible for the development of the common respiratory infection called the flu. Its genome is very unique in the sense of viruses compared to human cells. So again, it is a RNA sense genome that requires particular polymerase that is essential for the replication of genome and the production of mRNA, which encodes for proteins as the heterotrimeric complex, or the 3P. So the polymerase, or the 3P, it has 3 distinctive subunits called PA, PB1, and PB2. These subunits act as a singular function unit during the essential replication and transcription process, but also have their own roles and interactions when they're not coupled together. And according to literature, there are 100 of host interactions with the trimeric complex and just a few interactions without the complex fully combined. So my hypothesis.
RNA polymerase complex, the 3P, is a major contributor in the viral life cycle and a key regulator molecule in the interactions of hundreds of other host proteins. So this polymerase is thought to interact with numerous host proteins during these events and is thought to play a critical role in the pathogenicity as well as assist in host range restrictions. And previous work through my research advisor has identified the apoptosis factor AFM1, which is a flavonoid protein, is a putative binding partner for the trimeric complex specificity to the PA subunit alone. To the right is what the polymerase actually looks like. So as you can see, there's the PA, PB1, and PB2 subunits combined. So some of the techniques I used. So I use a wide variety of techniques in the lab and a really hands-on experience that Fisher has granted me, and I'm so thankful for it because it has really set me up for future events. So I use a series called cell culture, which is using two different distinctive continuous cell lines. In the top left is the HEC293Ts, which are human embryonic kidney cells. And in the bottom right is A549s or adenocarcinoma cells. I also use a technique called the Western blot, which is used for protein analysis. And as you can see on the top right image, we are actually probing for GAPDH, which is a essential sort of housekeeping regulatory in protein. I also use a series of DNA transfections, which we do is take the viral DNA and the protein that we're looking for, insert it into the cells, and then understand and evaluate the protein production. We use a series of different transfection agents called Optimem or lipofectamine, just some of those sort of generic uses in our lab. So some of our results. So I've been working on this project for 3.5 years. I've struggled for 3.5 years. And it has been super challenging due to COVID and working in the lab, and doing all the restrictions that were placed on, budget limitations, and a whole slew of different problems. But in particular, we have really struggled with identifying the PA subunit in our Western blot procedures, and it really has limited our capabilities of progressing forward with our research project. We have been able to identify AFM1, which is the apoptotic factor 1, but it really has not being able to identify PA has really stopped our progress. And we have sort of translated back to troubleshooting our Western techniques and using different series and assays. We've used different antibodies, which is located in the center of the image here. We've also tried to, collaborate with different students to see if, hey, maybe I'm doing something wrong. And in fact, I've even had my research professor or my advisor come in and do some experiments with me just to make sure that I wasn't messing anything up. So as you can see, the PA antibody is really our problem in progressing forward. And as you can see on the left, top left is a Western blot. This is just looking at tubulin, but it really gives you the sense of if we can't identify the protein, then we can't identify the translocation and the binding of AFM1. In the bottom left is a co-IP or co-immunoprecipitation to actually identify and understand the interactions that are occurring between the two proteins. Top left is immunofluorescence, which we are hoping to at some point complete within the 2 weeks at the end of the semester. But it really to identify the location of where the AFM1 and PA interact, and then its movement throughout the cell in order to identify some of its features, what it's actually doing, and how it's sort of co-mingling inside of the cell. Does it interact with other proteins? Does it interact with the DNA specifically? Where does the breakdown, because apoptosis is controlled cell death, so where does the breakdown of the cell actually initiate? And in the bottom right is just another example of immunofluorescence, but it really does show the distinctive differences in the use of different antibodies that are essential for our flagging purposes. So some future directions. So what are we currently doing? How are we going to move forward? Because this has been a struggle. And like I said, it's been 3 years and I have very, very limited data. So we're currently troubleshooting our Western blot techniques and transfection methods using a slew of different reagents, new antibodies, which has been a struggle because of the budget limitations, but we've been trying our best in order to do everything we can. We also in the process, and it is not just me, it's a group of us in creating a GFP producing plasmid so that we can actually, not use an antibody because antibodies are extremely expensive. So we actually found a way around our particular problem in order to sort of try to troubleshoot that method. And what we're trying to do currently is identify that location, the movement of AIFM1 without the PA interaction. So if we are capable of flagging the apoptotic factor, we can also understand and see its translocation and movement from the mitochondria to the nucleus to where we think the breakdown is actually occurring. And then what could be done in the future? So upon the identification of PA, we could begin transfecting PA and AIFM1 inside of the eukaryotic cells and using immunofluorescence to track these movements of the two proteins. I also have been in the process of sort of designing these these next two steps for our experiments and using live viral infections to actually understand the level of expression of these particular proteins and then also its binding of these proteins. So does a live viral infection actually, cause a slight decrease in the amount of protein present, therefore our binding interaction is not seen? Or does it actually overexpress these proteins more so than what we're doing currently, to where the binding is actually efficient and we can actually see what's going on? We also want to use a time measurement to understand at points which the translocation actually occurs. So in doing so, after about 10 or 15 minutes, and I know it sounds kind of tedious, but actually understand and visualize where we are moving inside of the cell using particular assay developments and a time stop method. So I just want to acknowledge a few people who aren't on the session today. So my research advisor, Dr. Janelle Maticio, she has been incredible and awesome to work with. She really does focus all of her energy on her students and tries to, support me the best way I can. And believe me when I tell you I'm a handful. So I also want to thank my research lab partners, Senior Dan Woodford and Bashoy Ibrahim. Both of these guys joined the project in the beginning of their junior year. We've tried our best in order to circumvent these circumstances, but it is what it is, and we're trying. I also want to thank the St. John Fisher Biology Department for giving me such great support and a network capability. All of my professors are willing to sort of help out and join and kind of give me some of the resources and supplies that I don't have, but we need to move forward. So I want to thank them. And then I also want to thank the Rochester Academy of Science for giving me my grant funds that were so needed in order to sort of progress forward. So if you guys, that's the end of mine. If you guys have any questions, please feel free to enter them in the chat. And then we, I'll try my best to sort of answer anything. Oops, I don't know why I can't. Okay, there it is. Couldn't see the bar. All right, thank you.
So it's my absolute pleasure to have been here to share my good colleague and friend and mentor partner, Dr. Sarah Goodman, our phenomenal seniors, Molly and Andrew. Going to be really hard to let you go. Graduation is always so emotional. I'm almost okay that I'm not in the room so that I don't have to carry Kleenex with me. And I would love to thank Tina and Matt for inviting us and turn things back over to Tina. Thank you.
Thank you all so much. If you have any questions, pop them in the chat at this time. And if we don't see any in there, you're always able to let us know. Oh, we're getting some congratulations to all of the panelists and best of luck to our seniors. We love to see that.
Thank you very much.
Okay, we'll keep an eye out on that. In the meantime, thank you all again for joining us today. We will share a link to all of you who have registered for the event today so you can join the symposium next week. Wonderful things to come, so I know you'll want to be part of it. If you do have additional questions that are not answered today, you can always reach out to the alumni at sjfc.edu email, and we will happily funnel them to who they need to go to. Our next First Friday lecture will be on Friday, May 7th, where we will discuss various innovations on campus, including the new DePeters Family Center. So let's check the chat one more time before we sign off. Oh, Deborah. How do we view the upcoming symposium? I will send out a link for everyone to view it. So hopefully that will help. And then more congratulations and thanks are coming in. So we will end on a high note. Thank you all again for joining us today, and a special thank you to all of our panelists. Our seniors, best of luck to you. We are so proud that you will be Fisher alumni. So thank you all again.
Thank you for having us.
Thank you.